Happy Ice Day, everybody. I hope you are all enjoying your extra day at home. However, we need to continue moving on in AP so that way we are staying on track to be ready by the time the AP test comes around. So what I'm going to need you to do is do the all things being equal activity parts 1 and 2. So I'm going to make this video for part 1, and then I have a separate video for part 2, so you can make sure that you have the questions answered so you'll be ready to go for part 3 when you come to class tomorrow on Wednesday. So I'm going to go ahead and start with part 1 of the all things being equal activity. Before you watch this video, please make sure you've read through the background information. Please make sure that you've read through the procedure for part 1 so you have an idea of what I'm going to be doing here. And also, we just need to talk a little bit about reversible reactions. So usually we talk about chemical reactions being unidirectional, meaning reactants form products. However, the truth is most reactions are reversible reactions. So a couple of examples of that, really simple examples, like an ice cube, for example. Ice cubes can melt and turn into liquids. They change from a solid to a liquid. We could write that as if it's a chemical reaction, even though we know it's a physical change. However, because of the change in state of matter, we could put it into a chemical reaction type format. However, liquid ice, also known as liquid water, can solidify back into an ice cube relatively easily. So that's an example of a reversible reaction. We could also look at the dissolution of sodium chloride in water. So if I take salt and I put it into water, it separates into its ions. So it goes from solid sodium chloride into aqueous sodium and chlorine ions. However, if I leave that container open to the surroundings, the water will evaporate and the aqueous sodium and chlorine ions will then recombine and turn back into solid sodium chloride. So those are two pretty simple examples of reversible reactions. We will talk in class about some more complex ones, but the idea is that a lot of reactions have both a forward and reverse component. Not every reaction, but a lot of them. So what I'm going to do here, I have beaker A. Sorry, let me switch these so they match the whiteboard. I have beaker A, which currently contains water with green food coloring, 700 mils of it. I have beaker B, which contains nothing. I'm going to go ahead and follow the procedure in the all things being equal activity. So 700 mils, no mils. I'm going to transfer water from A to B, then B to A using different beakers. Here's my 100 milliliter beaker, and here's my 50 milliliter beaker. And I'm going to continue doing that, recording the volume for every cycle. And a cycle includes one transfer from A to B, then again a transfer from B to A. That would finish one cycle. I'm going to move my beakers closer together to reduce spilling. Okay, so I got my 100 milliliter beaker. I'm going to go ahead and start my first cycle. So I took my 100 mils and I dump it into there. And then I'm going to take my 50, get as much as I can, and dump it into there. So after one trial, I have about 620 in my beaker A and about 80 in my beaker B. So let's go ahead and record that. Please excuse my handwriting. I am writing backwards, so it shows up appropriately on the screen. So wish me luck. So I have about 680 mils in cycle 1. Oh, that's a huge 6. Let me go ahead and change that. 680. And I have about, oh, I'm sorry, not 680, 620. And I have about 80 in my beaker B after cycle 1. And at the end of the video, I will go ahead and take a shot of the actual whiteboard once it's filled in. So don't worry about if you can't read it right now. So I'm going to go ahead and repeat that process, recording every time. 100 milliliters from A to B. I have about 550 in beaker A and about 150 in beaker B. Same thing. about 490 and 220. Sorry, 210. About 420 and 280. I'm at about 400 and 300. We're at about 350 in each. Got about 400 in beaker B. And 300 in beaker A. So I still have about 400 and 300, so I'm just going to put 8 with these repeated because it's the same. And again, still about 400 and 300. All right, so now, unfortunately, I am at 450. Oopsies, backwards. And 250. Trial 11, or cycle 11, same, 450 and 250. And cycle 12, the same, 450 and 250. And cycle 13, the same, the 450 and 250. All right, so that's our endpoint. It's said to continue until the level of in the water in A and B are unchanging for at least 4 cycles. So we got to our 4 cycles. So you can see our 2 different beakers, beaker A and B. And again, I will give you a close-up of the data table in just a second. So at this point, what you need to do is you need to do the data table and analysis questions. You'll notice that the data table says prepare on a separate sheet, so go ahead and make sure that you do that. It also says to create a graph using the data. Make sure you do this on graph paper. You can feel free to do it digitally if you so choose. Just make sure that you choose a scatter plot and then, or I'm sorry, you choose a line graph because I do want you to connect the dots. But it does say to make smooth curves, so you might want to do the dots digitally and then connect it with a pencil or a pen or something by hand. The other option is to get some graph paper from online. If you just search graph paper, conveniently graph paper shows up. The other option, if you don't have access to a printer or a graph paper, is to create your own graph paper using lined paper. You just need to use a straight edge to do the vertical lines. Just make sure that you have consistent intervals. Also, when you are answering the questions, the first question under B says, what do you think is meant by equilibrium? Please write down what you think it is based on this demo. Please don't look it up because later on in the questions, it'll have you look up the definition. You don't have to worry about comparing your ideas to other groups because obviously you are at home and that's not something that I can require of you. But make sure you do watch the video for part 2 and complete that as well. I expect when you come to class tomorrow, you have parts 1 and 2 of the All Things Being Equal completed. You do not have to print the activity packet from Moodle, but what you do need to do is answer the questions on a separate sheet. So go ahead and just create a separate sheet that says part 1 and then give your answers under each question number, and then do the same thing for part 2. And again, please make sure you also do your graph. If you want to print out the pages for parts 1 and 2, you may, but I will have them for you tomorrow in class. I hope you all have a great day, and I will see you tomorrow where we will continue this and do part 3.